Okay, why don't we get started? Welcome everyone to JJMO's virtual Second Saturday Stars. It's been a long time since we've been able to see you, and we've missed you, and hopefully you've missed us too. Today we have a program with a few short segments, but before we get started, we're just going to go over some basics on Zoom, just so that we're sure everyone knows how to participate to the best of their abilities. So first off, a couple of pointers for Zoom. You're going to see this once we get out of screen share mode, but you have multiple windows or buttons that you can press. Up in the upper right hand corner, there's a full screen mode. To the left of that, you have a choice of speaker view, which will show just the speaker, or gallery view, which will show everyone who's attending. We recommend that you use speaker view for this presentation. You also have a choice of turning your microphone on and off through the lower left-hand microphone button, and you can turn your video on and off. During the presentations, we will make sure that all of your microphones are off so that we don't get any stray noise in the presentations. It's your choice whether to display your video or not. If you feel that the presentation isn't coming through clearly, we'd recommend that you turn your video off so that all the bandwidth is for the incoming presentation and not being used to send your video to Zoom. Right in the middle of the screen, there's a button that says chat. And when you click on that, a chat window will open up and you'll be able to type a message to anyone on any of the attendees or to me. And if you were to click on the participants button and the chat button and go into speaker view, this is what your screen would look like. Of course, that's one of our younger presenters in the middle speaking. And on the lower right-hand corner, you can communicate with us, even if you're muted, by typing in the chat window. Another way that you can communicate with us, in the middle of at the bottom of the participants window, there's an ellipsis, and if you click on that, there's a button to raise your hand. When you raise your hand, then we'll be able to see you and we can recognize you and unmute your microphone so you can talk to us. If you happen to be using an iPad, all the controls are the same, they're just in slightly different places. I'm not sure why, but that's how Zoom has worked it out. The audio on and off is here in the upper to the right-hand side, middle right. Next to it is the video. And in order to raise your hand, there is no pop-out participants window, but you have to hit this more button. And from there, you can raise your hand. Okay, and on the upper left is where you change from speaker to gallery view. You can see here that this is where you chat and raise your hand is through the more button on an iPad. Now, those are just basics. Hopefully that's all you need to know to listen to the presentation tonight. I am going to pass it to Roger now. I'm going to make him host so that he can give us his presentation on what we can see in the night sky right now.
All right, very good. Am I on?
Yes. You are
Okay.
now there.
I am there. So let me share my screen with you.
Roger, do you have your your swim trunks on?
No, that's in South Dakota, Doug.
Oh, okay. You look like you're broadcasting from down near the lake.
No, no, that's just a virtual background. So good evening. I wanted to talk about what's up in the night sky for the next, excuse me, I'm getting a request to enter here. All right. What's up in the night sky for the next month. And to do this, I'm going to use screenshots, screen grabs from a program called Stellarium. This is the website, stellarium.org. Stellarium is it's a wonderful, full-featured planetarium program that is free to download and install. Although if you do end up liking it and using it, they do take donations. It's available for all three of the major operating systems. It's also available for Android and iOS, although those versions are not quite free, but the cost is nominal. And if you don't want to install something new on your computer, there's also a web version you can run right in a browser window. So usually I'll start off looking to the south, at least from my home especially. I have a clearer view to the south than in the other direction, but that's also where most of the more interesting things are as far as I'm concerned in the night sky. And this is what you see about 9 o'clock tonight. This is the band of the southern Milky Way, the summer Milky Way, sorry. And the center of our galaxy is somewhere down around here. But you see those two bright objects right near the center of the view. Well, those are not stars. That's our two gas giants, Jupiter and Saturn. So this is kind of unusual to have both of them up in the night sky at the same time. Jupiter orbits the sun about once every 12 years. Saturn about once every 29 years. So for them to be lined up like this is kind of rare. And Jupiter, well, Saturn's about twice as far away from us as Jupiter is. So I got to thinking, well, here's a puzzle for you to think about for the next couple of minutes. So what about next year? If Jupiter orbits the sun a little better than twice as fast as Saturn does, when we get around our orbit back to the same area next year, what about those two planets? Will they still be visible? Will they be close together? Will they be totally apart? Will they be in the same order? Just something to think about for a minute. So if you wait a month, let me go back to this for a second. So this is what you see at 9 o'clock. As the night progresses, of course, everything is going to shift to the west as the Earth rotates. And not only will that happen if you're outside, but if you leave Stellarium running on your computer, it will do the same thing. It will track the Earth's rotation and show you things moving across the sky. So if you wait a month and look out at the same time of night, this is what you'll see. Notice the two giant planets have settled further in the southwest. They've become dimmer because we're moving away from them. But we also have a new guest up in the upper left, which is Mars. Now, you don't have to wait till next month to look at Mars. If you have a clearer view of the east horizon and you wait about an hour or maybe two tonight and you go outside, you'll actually see it just rising in the east. But at least by next month, it'll be up high at a reasonable time. So getting back to my puzzle, what about next year? If you thought about this for a minute, and what you can do this with Stellarium is just plug in the date and time for a year from now to see what's going to be up. And you'll find that Jupiter and Saturn are once again back in the night sky, but notice they're farther apart and they shift the position. Tonight, Saturn is to the left of Jupiter, and a year from now, Saturn will be to the right of Jupiter. And that's simply because Jupiter has progressed further in its orbit than Saturn has. So once again with Stellarium, you can zoom in on any object that you that you're looking at. But this, I tried to simulate what Jupiter would look like if you had a good pair of binoculars. So if you have a good pair of binoculars, go ahead and go outside and look at Jupiter. And one thing you notice is that it is a disk rather than a pinpoint. So any star, if you look at it in binoculars or even a telescope, is still going to be a point of light, whereas a planet will show a definite disk. So you see a disk for Jupiter. You might also see some of the Galilean moons, tiny little dots you see lined up alongside the planet. And if you zoom in even further on the same program, you'll get a more magnified view. And you can even find, see where the Galilean moons are lined up. Now this is going to vary hour to hour and day to day, so you won't see this alignment each time. But you can look up exactly where the moons are, exactly at the time you're interested. If you left click on an object in Stellarium, you'll get a whole list of information on the left side, tell you what type of an object it is, how far away it is, its altitude, its azimuth, celestial coordinates, almost anything you might want to know about that object. And you just right click to clear that information again. So still facing south, if we look straight up, you'll see one of our favorite asterisms, that is star groupings, and this is called the Summer Triangle. And this is composed of 3 stars, Deneb in Cygnus, Vega in Lyra, and Altair in Aquila. Funny thing, we had this discussion the other day about Deneb. For years, Deneb was thought to be about 2,600 light years away. And it's one of the most luminous stars in the Milky Way. But more recently, they've changed that figure to about 1,500 light years away. And they're still not sure. And the reason is Deneb is such a bright star that it actually saturates the sensors of the satellites that are taking these measurements. And when it saturates the sensor, it's difficult to tell exactly the position of Deneb in the sky, which makes it difficult to tell exactly how far away it is. So they're still working on it. But Vega is 25 light years, Altair is 17. Vega is the 5th brightest star in our night sky. Now let's turn around and face north. This is the view. These are the stars you'll see pretty much all night, every night, facing north from our latitude. They will simply appear to rotate around the central point.
Watching the Zoom video from second Saturday. Intending.
There's the Big Dipper, there's the Cassiopeia, and they seem to rotate around this central point, which is, of course, Polaris. And as we've pointed out before, the easiest way to find Polaris is to find the end of the bucket of the Big Dipper and just follow those 2 stars, and it'll point almost directly at Polaris. So that's facing north tonight. Wait a month, view hasn't changed much, it's just rotated a little bit. And that'll be true for the whole season, that you'll find the Big Dipper, sometimes it'll be near the horizon, sometimes it'll be up at the top, and left to right, but it'll always be rotating around the central point. Getting back to Mars for a minute, Mars will be at opposition on October 13th. Opposition simply means it's exactly opposite us from the sun. If the planets were in a circular orbit, that would also mean that's when it's closest to us, but of course we're in elliptical orbits. So Mars is actually slightly closer to us, or will be slightly closer to us on October 6th than it will be on October 13th. But what opposition also means is that the planet will be up all night, rise at sunset, and it'll set at sunrise. And if you're a morning person, which I am not, but some people get up before sunrise, this is facing east. Well, this would have been 5 o'clock this morning. And you notice you start to see a winter constellation here, Orion. And you'll see the moon and Venus. And then if you wait just a month, you'll notice the same thing. Orion's higher in the sky now, and Venus is lower in the sky. But this is amazing. On this day, if you go outside, in one 24-hour period, you can see 4 planets. You can see Venus in the morning, Mars, Jupiter, and Saturn in the evening. That's absolutely amazing. What a special treat. So the fall equinox arrives September 22nd at 9:30 in the morning. Actually, I should call that the September equinox because it's the fall equinox for us, but it's the spring equinox for the southern hemisphere. That simply means that the sun's rays are shining directly over the equator. Equinox is equal day, equal night. This is astronomical fall. This is the beginning of astronomical fall, as opposed to meteorological fall. If you watch the network news channels, meteorological fall actually began September 1st. And they simply use 3-month blocks to define the season. So meteorological fall runs from September 1st to the end of November. And last, just the moon phases for the month. So we started off with a full moon on the 2nd. This is the most difficult time to view deep sky or dimmer objects because the moon's glow, the moon's glare kind of washes them out. Best time to view the dimmer objects is when there's no moon in the sky. Best time to view the moon is in these early waxing phases, where you have these sharp contrasts between light and dark.
What do we do here?
That's the story. That's the summary of what's going on in the night sky.
That's Roger Moore. Okay.
At Enterprise, peace of mind starts with our complete clean pledge. Curbside rentals
And
and
if-
low-touch transactions. With
if
so many
you go
vehicles
up-
of so many
I don't know,
kinds,
did the
you can
audio
count
go
on
off?
us to help you get everywhere you want to go.
Can't find out how to unshare my screen. I seem to have lost it. Oh, stop share. There we go. Okay. I will entertain a couple of questions. We don't have a whole lot of time, but if anybody has a question, I'd be happy to try and answer it or make something up.
Percent of places in the U.S.
No questions? All right, then I will turn this over to Bill, I think, right?
Yes.
Is that DC? Is that what I see you, Bill?
Yes,
All right.
John, do we have everybody muted?
we don't. And once you get host, before you start sharing, you might want to mute all.
The perfect setting for the captain of the star. Here comes Jamie Bell with a shot.
If you go sit in the living room and just go sit in the living room.
All right, Bill, you have host.
That's her.
But Anton Hudobin stood tall. So too would Robin Leonard. Here's Fred.
Okay. I think I muted everybody.
Okay.
Okay. Everybody see that?
Yes, Bill?
Yes, we do.
All right.
Yeah.
Perfect.
Okay, well, Roger mentioned a little bit about Mars, and actually last night was a beautiful night to have gone out on your back deck and taken a look, because there really isn't much else in the eastern sky around 10 o'clock except for this very bright, ruddy colored object.
Just quiet a place so they don't get the noise from the TV.
Okay. So I was going to talk a little bit about Mars because it's a great year for a number of reasons. This is a view looking down at the solar system. Roger mentioned stellarium as an interesting resource. This comes out of the JPL Solar System Simulator, which again you can go online and use and reconstruct views of the solar system for any time and date. So this is tonight. You can see that the Earth is moving towards an encounter with Mars. And as Roger mentioned, they'll be closest on October 6th, and Mars will be opposite the sun in our sky on the 13th, which is what we call opposition. So you can see that the orbit of Earth is elliptical, but it's more circular than Mars. Earth's orbit only varies by about 3.5 million miles from its closest approach to the sun to its furthest. Mars, on the other hand, varies as much as 26 million miles. So not all encounters are equal. This is a fairly good encounter this year for a number of reasons. And around this time, when the Earth and Mars are approaching each other, and it happens about once every 26 months, this is the opportune time to travel to Mars. It takes you the minimum amount of fuel, and it's also the quickest, roughly 6 to 7 months travel time. So as a result, we had 3 different countries launch spacecraft to Mars in July. The first one to launch was from the United Arab Emirates. They built an orbiter that's going to Mars. They don't have a spaceport, so they arranged to have their orbiter placed on a Japanese rocket and launched from Japan. About a week later, the Chinese launched a very ambitious mission. They'll be putting an orbiter around Mars, and the orbiter will be scouting locations to put down a lander and a rover. So for their first mission to Mars, it's not only complex, but it's a fairly ambitious mission. And of course, at the end of July, the United States launched their mission to Mars, called Mars 2020, and that will carry a rover to the red planet. We have a rover on Mars right now called Curiosity that's exploring Jezero Crater, looking for the right chemistry for life. This particular mission has many similarities. It's built on the same platform, but we're going to be looking for signs of ancient life. We're going to be collecting samples, and we're going to be sealing those samples up and leaving them at a designated location on Mars to be picked up later on. In fact, there is a sample return mission in the planning right now that will collect those sample tubes and bring them back to Earth. This mission also has a number of new technologies that we're trying out. Because the area that we're going to land in is fairly rugged, we've developed a terrain relative navigation system where, as the spacecraft descends through the atmosphere, it can take images of the landing area and adjust accordingly to put itself down in a safe configuration. We are also going to be demonstrating a helicopter, the first time another aircraft will be flying on Mars. And you can imagine this is pretty challenging because Mars' atmosphere is 100 times thinner than on Earth. So they had to develop a helicopter that could fly in such thin air. The rover will also have some self-driving capability. So we expect to cover a lot more ground now that the rover can make some judgments on how far to proceed, how fast to drive, and how to get to a particular location. There's also an interesting experiment called MOXIE, which will be extracting the Martian atmosphere and separating the components to remove the oxygen. So that's something that future expeditions, colonists would find very useful. And the rover will have some ground penetrating radar. So we'll be looking beneath the surface. There has been evidence of subsurface pockets of water. So that's something that we're interested in. And this is going to be a very interesting mission because we've got 23 cameras. So we're going to have views of the landing that we've never had before. In all stages of the mission, we're going to be able to cover it live with science cameras, engineering cameras, and we've also got a couple of microphones going along. So even though the atmosphere is very thin and we might not hear a lot, we're going to have our first sounds from the red planet. So right now, we're in the cruise stage. And if you're interested in software that's available out there, this is NASA's Eye on the Solar System, something you can download for free and use. You can follow any mission in real time, or you can go back in time and look at some of the old missions. You can look at satellites that explore deep space or that orbit the Earth. So these are snapshots from tonight. You can see that Mars 2020 is traveling to an intercept Mars in late February. And as I said, you can ride along with the spacecraft. So as the spacecraft moves and changes angles, you can see that happen in real time. So by the time our spacecraft gets to Mars, it'll have traveled about 300 million miles, taken about 7 months to get there. And then, of course, the last 7 minutes is the most critical because that is the entry, the descent, and the landing phase, the 7 minutes of terror, as the folks at JPL like to call it. So where are we going? Well, this is a color-coded map of Mars. The colors are based upon elevation. So to give you some sense of where you are, you can see that the northern hemisphere is blues, various shades, representing a lower elevation. There's some theory that at one time this area was an ocean, a shallow ocean. The higher elevations, of course, on the left side of the screen, you can see these little white bumps. These are the large Martian volcanoes. And the one furthest to the west is Olympus Mons, the largest volcano in the solar system. You can see this feature here. This is Valles Marineris. This is the largest canyon on Mars. If you took this canyon right here and you placed it on the Earth, it would stretch from one coast of the United States to the other. So it's a fairly large feature, probably a stress feature where the crust is actually separated. But way over here to the right, you see the circular feature right here. This is Isidis Planitia. This is our destination, the Mars 2020 mission. Looks like a possible impact feature long ago. Zooming in a little bit, you can see that we're going to be landing in a place called Jezero Crater. It's on the western shore of Isidis Planitia. And the interesting thing about this particular site, and this is one of many, many sites we're evaluating, but what folks really think about is that it appears that this crater was flooded about 3.5 billion years ago. And there's 2 inlet channels and 1 outflow. And when you calculate the volume of water that must have been in this crater for it to overflow and flow out of the crater, we're talking about something that's 50% more volumes than, say, Lake Tahoe. So it's a fairly good sized body of water. We think it was active for quite a long period of time. And inside there are some delta areas where the water was flowing into the crater. And we're going to the western delta. And here's a color-coded picture of this fossilized delta. So you can see why this is so intriguing to scientists. These are mostly clays, and clays preserve organic material. So if you want to look for any kind of fossilized remains, this is the place to go. And as you can see, it's also fairly rugged, which is why we have this new technology so that the spacecraft can make some last-minute decisions on where to set down safely and be able to explore this region. So as I mentioned, the last 7 minutes is critical. We're coming in pretty fast into the Martian atmosphere. Martian atmosphere is very thin, but it's thick enough to be a problem. So we have to slow down by a combination of heat shields, large supersonic parachutes, and then as we get closer to the surface, we have this device called the sky crane, which is kind of like a jet-powered a carrier that will lower the rover down the last few feet onto the surface. And then it will cut these cables and fly off, leaving the rover alone to begin its exploration. So that all happens on February 18th next year. So while we're waiting, now is a great time, as Roger mentioned, to go outside, take a look at Mars. It was very bright last night. It's going to be as close as 39 million miles or so in October. And the great thing is that it's going to be a lot higher than it was in 2018. If anyone remembers trying to find Mars in 2018, it was very low in the sky, very difficult to see. But this year it's going to be nice and high, which will allow us to get nice, clear views. So I'm going to leave you with a picture that was taken at 2 o'clock this morning by our ace astrophotographer, Mark Polanski. And he took a picture of Mars through an 8-inch telescope. And you can see he's picked up some details, some of the darker markings. He's picked up the northern hood, which is a envelope of clouds over the north pole of the planet. And you can see the very small southern polar ice cap. So this view is only going to get better in the next few weeks. But Mark's already working on taking some great images. So with that, I'll wrap up. If there's any questions, be happy to answer them. Otherwise, I'll turn it back over.
Very nice. Thank you, Bill.
All right, John, I sent it back to you.
Great. Thank you, Bill. So the next part of our presentation is going to be three short talks from some of the young astronomers that have been affiliated with the observatory. They're often disparate places, but this is one of the advantages of Zoom and COVID. So let's start out with Carly. Carly Kleinstern.
Hello.
Hi, Carly.
Hi, everyone.
Why don't you tell folks what you're up to?
Okay, sure, yeah. So hi, I'm Carly Kleinstern. I will give you a very brief synopsis of my journey through astronomy and physics. So I just finished my first year of the PhD program in physics at the University of Chicago. So I survived that whirlwind, which I'm very happy about. So I'm currently working in a particle physics group, where we're studying dark matter, in particular, very light dark matter. So first, you might ask what dark matter is, and the deal is that there is a lot of stuff in the universe, and we think about visible matter a lot, like people and chairs and books, but really it makes a very small fraction of all the stuff in the universe. And so what I'm doing at Chicago is trying to figure out what this mysterious other matter or dark matter is. So very lofty job, just a tiny cog in the whole machine. So before that, I went to Brandeis University and studied physics. And then before that, the super exciting part was that I was a volunteer and a researcher at JJMO. So my sophomore year of high school, I decided to start a project at the observatory, and I had many great mentors like Bob and Mark and Parker and Monty, and I really enjoyed learning about comets and telescopes and near-Earth objects and all this stuff. And so much so that I decided to become a volunteer because I wanted to, foster other people's learning and enjoyment of the heavens. So unfortunately, I don't participate too much in the observatory now because I'm far away in Chicago, but I'm very glad that I can zoom into this event, and hopefully everyone here can soon be at the observatory and actually looking through telescopes. So I'm excited to see you all. Thank you.
Thank you, Carly.
Yeah, thank you.
Thank you.
Louise,
Yeah, hi. So I'm Louise Gagnon. I am currently a rising junior at also at the University of Chicago. I'm majoring in astrophysics, and this summer I've been working as a research assistant with the UChicago Astrophysics Department. We're studying a very specific type of galaxy. They're called low surface brightness galaxies. So they're these very dim, very diffuse galaxies that we don't know that much about because they're very dim, they're hard to see. But by learning about them, we can understand more about how the universe formed and how galaxies formed. I guess that's kind of the big picture view of this project. And yeah, like Carly was saying, I am but a tiny cog in this large machine, but it's been just so cool to be able to be involved in this, in the science. And I think that's why JJMO has been so important to me. I think I also sort of arrived on the scene as a volunteer in 2015. I think my sophomore year of high school. And I did I believe I did an imaging project with Mark Polanski, where we took spectra of the passing comet. And I'd always been interested in astronomy, but being able to actually do some science on this real comet out there was just really incredible. And since then, I have created and taught a class at JJMO for middle schooler to high schoolers. And it's just been really, really fantastic to participate in outreach and also to have a hands-on experience with these astronomy concepts that I find so interesting. So yeah, I think JJMO is one of the big reasons I am where I am now. So thank you.
Thank you.
great. Thank you, Louise. And now, last but not least, one of our current young astronomers that are at the observatory now doing things, Andrew Grivner.
Hello, everybody. My name is Andrew Grivner, and I'm a...
I think you have to share your screen.
No, I don't have to share your screen. And I'm 13 years old and in 8th grade. And I originally found out about the observatory when I was in Cub Scouts. We did we have basically merit badges when you're in Cub Scouts, and one of them was for astronomy. So we went to the observatory when I was in 3rd grade And I became interested then and have been a volunteer basically ever since. So this is my 5th year volunteering. And as a volunteer, I've learned about the software and how to run the telescope. Some of my current interests are in computer coding and building computers. So that's about it.
Thank you, Andrew. Okay, so that is the end of our prepared program.